Good morning, friends. Welcome all of you to my channel on Structural Design 1. So far, we discussed about beams. ഏതെല്ലാം തരം beams ആണ് നമ്മൾ പഠിച്ചത്? The design of singly reinforced beams, doubly reinforced beams, T-beams, and the design of shear reinforcement in beams, and also about the bond development length and anchorage. These are the portions what have covered already in modules 1 and 2. Now, today we start with the module 3, discussing about slabs. What is the main difference between a beam and a slab? എന്താണ് എല്ലാവർക്കും അറിയാം, ബീമും സ്ലാബും തമ്മിലുള്ള ഡിഫറൻസ് എന്താണ്? The thickness of the slab is very less compared to its other dimensions, length and breadth. Usually, the slabs are designed for floors, slabs, that means roofs, staircases, water tanks, etc. Right? You might have seen the slabs designed for a structure. It's a structural member widely used, and the main difference is that the thickness of the slab is very less compared to the other dimensions. So therefore, the design parameters are also different in the case of slabs. Now, there are different shapes for the slabs, maybe a rectangular slab, square, circular, of any shape. And what about the design parameters, or what are the things to be considered in the design of a slab? So these are the topics what we are going to cover in this module in slabs. And you might have seen that the design and the construction or the casting of a slab is different than that of a beam. What is the difference? When we consider the width of the beam, it is always, whether it is a single reinforced beam or doubly reinforced beam, its width will be specified, a 230 mm or 250 mm like that. But in slabs, the width of the slab is considered per meter, that is 1000 mm always. B is equal to 1000 mm for the design purpose. So per meter width of the slab. So that is one difference. And another difference, in slab, usually no need of designing the shear reinforcement. Right? The shear reinforcement is not necessary because of the less thickness of the slab. But here we design the main reinforcement and the distribution reinforcement. The main reinforcement along the span and the distribution reinforcement in the transverse direction. So what is the purpose of providing this distribution steel? You know that the temperature or the shrinkage, to take the temperature difference or the shrinkage difference in the slabs always, because its thickness is very less and the area is more. The surface area is more compared to the volume of the slab. ഒരു സ്ലാബിൻ്റെ വോളിയവും സർഫസ് ഏരിയയും കമ്പയർ ചെയ്യുകയാണെങ്കിൽ സർഫസ് ഏരിയ ആയിരിക്കും ഒരുപാട് കൂടുതൽ വരുന്നത്. അപ്പോൾ അതുകൊണ്ട് തന്നെ അതിന് ഇൻ അഡീഷൻ ടു ദ വെർട്ടിക്കൽ ലോഡ്സ് എടുക്കുന്നതോടൊപ്പം തന്നെ ലാറ്ററൽ ലോഡ്സും അതിന് റെസിസ്റ്റ് ചെയ്യാൻ പറ്റും. ലാറ്ററൽ ലോഡ്സ്, അതായത് ഹൊറിസോണ്ടൽ ലോഡ്സും സ്ലാബിന് റെസിസ്റ്റ് ചെയ്യാൻ പറ്റും. ഇൻ സച്ച് ആസ് എർത്ത് ക്വേക്ക് ലോഡ്സ്, അതെല്ലാം സ്ലാബിന് റെസിസ്റ്റ് ചെയ്യാൻ പറ്റും. പക്ഷേ അതിന് ലെസ് തിക്നെസ് ആയതുകൊണ്ട്, അതിൻ്റെ ഏരിയ, സർഫസ് ഏരിയ ഒരുപാട് കൂടുതലായതുകൊണ്ടും അതിൽ വരുന്ന ടെമ്പറേച്ചർ വേരിയേഷൻസ് അല്ലെങ്കിൽ ഷ്രിങ്കേജസ് അതിനെ റെസിസ്റ്റ് ചെയ്യാനാണ് ഡിസ്ട്രിബ്യൂഷൻ സ്റ്റീൽസ് അല്ലെങ്കിൽ സെക്കൻഡറി സ്റ്റീൽസ് എന്ന് പറഞ്ഞിട്ട് നമ്മൾ പ്രൊവൈഡ് ചെയ്യുന്നത് ട്രാൻസ്വേഴ്സ് ഡയറക്ഷനിൽ. അപ്പോൾ നമ്മളൊരു സ്ലാബ് പറയുമ്പോൾ ഒരു സ്ലാബിന് രണ്ട് ഡയറക്ഷൻ അല്ല LX and LY. കൺസിഡർ റെക്ടാങ്കുലർ സെക്ഷൻ, റെക്ടാങ്കുലർ ഷേപ്പ് നമ്മൾ അസ്യൂം ചെയ്യാം ഒരു സ്ലാബിന്. അപ്പോൾ സ്ലാബ് റെക്ടാങ്കുലർ സെക്ഷനിൽ there are two dimensions, LX in X direction, LY Y direction. അല്ലേ? The two dimensions in X and Y directions. ഇപ്പോൾ നമ്മൾ പഠിക്കാൻ പോകുന്ന രണ്ട് തരത്തിലുള്ള സ്ലാബ്സ് ആണ്. നമ്പർ 1, one way slab, one way slab, and 2, two way slab. ഇത് രണ്ടുമാണ് നമ്മുടെ സിലബസിൽ നമുക്ക് പഠിക്കാനുള്ളത്. എന്താണ് രണ്ടും തമ്മിലുള്ള ഡിഫറൻസ്, അതിൻ്റെ ഡിസൈൻ പാരാമീറ്റേഴ്സ് എന്തൊക്കെയാണ്, എങ്ങനെയാണ് നമ്മൾ ഒരു വൺ വേ സ്ലാബും ഒരു ടു വേ സ്ലാബും ഡിസൈൻ ചെയ്യാൻ പോകുന്നത്, ഈ കാര്യങ്ങളാണ് ഇതിൽ ഡിസ്കസ് ചെയ്യുന്നത്. വാട്ട് ഇസ് മെൻ ബൈ എ വൺ വേ സ്ലാബ്? വൺ വേ സ്ലാബ് എന്ന് പറയുമ്പോൾ സി ഫ്രം ദിസ് ഫിഗർ the dimension in the X direction, the dimension in the Y direction. It's a rectangular shape. Okay. Now here this LX is shorter than LY. Suppose LX is shorter than LY, and the reinforcement provided along LX, the reinforcements or the steels provided along that direction, the shorter direction, is the main steel. The main reinforcements will be provided along the span. The span means there is a shorter measurement, that is LX, and in the other direction, see, these are the distribution steel or secondary steels provided in the perpendicular direction or in the transverse direction. That means along LY. So here, how can we decide whether it is a one-way slab or two-way slab? That according to the ratio, if Ly divided by Lx, Ly by Lx is greater than 2. The two dimensions, X direction, Y direction, take the ratio Ly by Lx. If it is greater than 2, it is a one-way slab. We have to design it as a one-way slab. For example, the slab for a veranda, the roof slab for a veranda, the length will be more, one dimension will be more, the other dimension will be less, shorter, isn't it? So that direction is taken as the span. So this is the span here, the shorter direction. So the main reinforcements will be provided along the span. See here, these are the main reinforcements. The reinforcements provided in the transverse directions are known as the distribution steel or secondary reinforcement or temperature reinforcement, like that we can say. It's clear? Now see here, the bending, the curvature of bending will be along the shorter direction like this for a one-way slab. Now take the second case, two-way slabs. What's a two-way slab? See here, Lx and Ly, the dimension in the X direction, the dimension in the Y direction. So here, if Ly by Lx is less than or equal to 2, less than or equal to 2, then that slab is considered as a two-way slab. That means approximately it will be a square. Ly by Lx less than or equal to 2 means approximately it will be a square shape. So in that case, both the directions to be considered as the span, right? Lx span, Ly span, and main reinforcements will be provided along both the directions. See here, these are the main reinforcements in the Ly, these are the main reinforcements along Lx direction. So both are the main reinforcements to be designed. See the curvature of bending in X direction, curvature of bending in Y direction. So that depends upon the room size. We will design it as a one-way slab or two-way slab. So when we study now after this the design criteria, and to design a slab for one room, the dimensions of the room will be given and the material properties will be given to you, right? And according to that dimension, first you should check whether the slab is one-way slab or two-way slab as per the given ratio Ly by Lx. If it is greater than 2, it is to be designed as one-way slab. If it is less than or equal to 2, the beam should be designed as two-way slabs. So these are the two type of slabs we are going to study in this topic, the design and the detailing of reinforcement. How to provide the main bars and how to provide the distribution steel at the top. The main reinforcements will be provided at the tension side and the distribution steel at the top, right? And no need of shear reinforcements in this case, the design of slabs. Is it okay? Is it clear? So in the next video, we'll discuss about the design parameters and we'll do one problem to design a slab after checking whether it is one-way slab or two-way slab as per the design parameters according to the norms in the code IS 456. I think it is clear to you. Okay. Thank you. We'll meet you again in the next class.